I will talk about that in future, but for now let me to say that this is a converter between the electrical and between the electricity and also the optical pulses, because you know that in switch we are using the electrical for example electrical voltage or current for sending the data, but in fiber we can send only the optical pulse. This means that assume that one switch needs to send one bit into the for example fiber link. You know that when a switch in with electricity needs to send the bit of 5, for example, assume that it should send the 5 volt the 5 volt voltage, and for 0 bit it should send, for example, this is only one example, or plus 1 voltage. But we can send the voltage or electricity into the optical fiber. Because of that we need to convert it to a special type of frequency, a special type of optical pulse, and this is the job of this converter. Okay, this is the converter or transceiver. Okay, we need to connect these converters into the switch, and after that we can connect the for example fiber links, different type of fiber links to the switch. Look at here you can see it, the slot is empty. After injecting this for example converters, we call them SFP or a small form factor pluggable, into the switch, we can connect the optical fiber to the switch. Okay, this is one example. But now here between the switch, as you can see, I use the fiber link. This means that I use these converters, and after that I connected one fiber link between the switch 1 and switch 2. Also, maybe in some switches you will encounter with switch that support built-in converters. Because of that you don't need to attach or inject a new converter into that switch. Okay, this is possible. Here we have a scenario. In this scenario I'm going to talk about one important things, and that is that you can use, for example, in the link between switch 1 and PC1, the Cat3 cable. You know that the Cat3 cable only can support 10 megabit per second rate of the data. Let me write here. This means that we can send only 10 megabit per second of data and also receive 10 megabit per second of data on these links. Also here we have another twisted pair, as you can see, between the switch 2 and PC2. We can use the, for example, Cat5e. This is the Cat5e cable between the PC2 and switch 2. You know that the Cat5e support up to 1 gigabit per second. Let me write here 1 gigabit per second. And after that, for example, between the PC3 and switch 3, we can use a Cat5 cable. Cat5 support up to 100 megabit per second. Okay, this is the 100 megabit per second. Let me write here. Okay, this means that we can use different categories, different cables or twisted pair cables in one network with different rates. It's possible. Okay, also as you can see here, we are using the fiber link. About the fiber link also, we have different speeds and different distances. For example, here I'm going to use one fiber link that can forward 1 gigabit per second of data, and here I'm going to use the fiber link with 10 gigabit per second of data rating. Okay, this is possible. Why this is possible? Maybe this is the question that you have. The reason is that in Ethernet, okay, we are sending the same frame over different for example physical media. Let me to review some of the topics about the Ethernet. You know that Ethernet is working on the data link layer of the TCP/IP and also on the physical, and the function of Ethernet in data link and physical is related to each other. But when you are using different Ethernet media types, okay, and then for example different Ethernet cables, Cat3, okay, Cat for example 5 or Cat5e, or also for example 1000 base SX, means the fiber with short wavelength, or 10G base LX, for example. Here we have the same framing. This means that I will show you the framing. You know that when we are receiving a packet from our computer, this is a packet, we need to add the data link header here, Ethernet ETH header. Okay, this is the Ethernet header, and also ETH trailer. You will learn about it in this video or in the next video. And here, when we created the frame, this is a frame, this is the Ethernet frame after adding the Ethernet header and Ethernet trailer. Okay, this is not important that we are sending this packet on which type of the physical link, for example in Cat3, Cat5, Cat5e, or for example also over the fiber link. Because of that, the framing is not different in different physical links. Only the speed of the forwarding is different. Let me to give you one example. Assume that I and you were talking with each other in English. I and you, both of us, can talk with English language, okay? But I can talk English faster than you, okay? I can reduce my speed in English talking, okay, with you, and you can understanding. But I can also talk with another person that person has a higher rate of sending English words to me. Because of that, he or she should reduce their speed to talking with me. But all of us are talking with each other with English languages. Because of that, we can talk with each other, but with different speeds. This is so important. Because of that, when you are upgrading your networks from, for example, 100 megabit per second to 1000 megabit per second or 1 gigabit per second, some part of networks can work with 1 gigabit per second, and some part of the networks can work with, for example, 100 megabit per second. And finally, you have the time to upgrade all of the network to a for example, higher speed. This is the function of the Ethernet. The framing doesn't change between the different media types or different links. Look at here, we are sending the same frame here between the PC1 and switch 1 over a Cat3 cable, and again the same frame between the switch 1 and switch 2 over the fiber with 1 gigabit per second. And after that, for example, between the switch 2 and switch 3 with the 10 gigabit per second fiber, and also between the switch 3 and for example PC3. Assume that the PC3 is the destination PC. This means that the framing is not for example, changing between in different links. Only the speed is changing. This means that we can say that layer 1 attribute, okay, should be changed in different type of medias, but layer 2 attribute or layer 2 framing doesn't change. This is the Ethernet function. You will better learn better and better understand about the detail of this, because when you understand the function of the Ethernet header and Ethernet trailer, you can understand that we don't have any differences between the different type of the links when we are creating the frame. Okay, the only things that is different is the speed of advertisement and also the coding mechanism. For example, for coding, you know that in the 10 megabit per second, we have different type of coding, how we can code the bytes and bits into the voltage, and in the fiber link, we have different methods, how we can code the bits and bytes into the optical pulse. And for example, in different speeds, we are using different coding mechanisms. All of them are different. In layer 1, we have differences about the current, about the voltage, about the optical pulses, about the coding, and some features related to communication. Okay, but about the framing, means logical function of the Ethernet, we don't have any change. The frame of Ethernet on all of the media that Ethernet is supporting, the frame is same, and we don't need to change the frame over different media types. And this is one of the advantages of the Ethernet, because you can connect your network with any speed to other network with other Ethernet network with any other speed with the same framing. Okay, and this is one of the benefits of the Ethernet. Let me to give you one important information here. As I mentioned before, we have Cat3 with 10 megabit per second, okay, and also Cat5 with capacity of 10 or 100 megabit per second. All of the speeds, for example, the Cat5 can support the lower speed, The 1000 megabit per second means we are supporting both 10 and also 100 megabit per second of the speed. Again, here, look at here. We have, for example, Cat5e 1000 megabit per second or 1 gigabyte per second. It can support the 100 and also 10. Also, in higher speed, in the cable, we can support the lower speeds. And also, we have another important notation here. You know that we are using the IEEE codes for different Ethernet categories. For example, we can call it IEEE 8023I or 3. Or to Cat5, we can say IEEE 8023U. You learned about them in previous video. Or for the Cat5e, or for example, for the 1000 megabit per second with Cat5e or Cat6, we can say that we are using here in the Cat6, we are using IEEE 802.3, for example, AB. Okay. And in other standards, we have another codes. It's okay, but if you want, you can use one simpler name for talking about these categories. For example, we call the 10 megabit Ethernet simply Ethernet. But we call the IEEE 802.3U Ethernet simply fast Ethernet. When you say fast Ethernet, I can understand that you are talking about the 100 megabit per second Ethernet. That's it. When you say we have, for example,